Those days, having a RAG pipeline in your AI application is quite common. And what RAG does? It already provides the possible answers or responses according to user query, even without consulting to an LLM. But RAG is not all about AI. Only the small part in RAG, that is generation, Retrieval-Augmented Generation. The last part is only about AI. The majority of the RAG system is dependent on the retrieval of semantically similar information or text. In 2020, Facebook AI, which is now Meta AI, introduced this new approach, RAG, a pipeline which combines the retrieval of the semantically similar text with LLM capabilities. And they called it RAG, Retrieval-Augmented Generation. In RAG pipeline, the knowledge base is created in vector database. You would have heard the names of Pine, Fez, or Chroma vector stores. They are the implementation of the concept of vectors. While Meta AI introduced this approach of combining the retrieval of the information from a vector store with LLM capabilities, but they didn't invented this vector store or embedding model concept. It was existing way before even we heard the name of artificial intelligence or anything like that. In fact, the research around retrieving a text based on semantic similarity started in mid-1960. Yes, in mid-1960. The vector space model, which is fundamental behind this kind of retrieval system and representing text in the form of a number, which we call a vector in a multi-dimensional space, was formally introduced in 1978 by computer science professor called Gerard Salton. Gerard Salton was a computer science professor who was born in Germany and was working in Cornell University in New York, US. In vector space model, the distance between vectors or the angle between them was a key behind determining whether these two texts are similar or not. And this is still the key factor behind determining semantic similarity between text in vector store. When we say RAG, we immediately think about three things: retrieval, augmentation, and generation. But believe me, this is only the surface. In an effective RAG pipeline, there are much more things or layers to be considered, which are beyond these three things: retrieval, augmentation, generation. These layers include how your data indexing has been done. What is your chunking strategy? How is your, for example, retrieval scoring? And apart from that, you also should consider what is the orchestration logic, how you have implemented, which tools you have used to implement this pipeline, from caching to feedback loops to determine performance metrics. And each decision, each layer, each implementation actually impacts precision, latency, and overall user experience about the AI app. And the terms which I have just said, this orchestration, caching, feedback loop, chunking strategy, it's not about AI. It's really not about AI. It's about developing a effective retrieval system. If you want, you can still develop your, for example, text retrieval system even without UI, just by using this vector store. I thought of creating a few videos in this series about how to implement efficient RAG pipeline, where we will discuss the minute details, various aspects which are really beyond the buzzwords. These three things, retrieval, augmentation, generation, which most of the people think like RAG is all about. We will see code samples about how to do, for example, chunking, how to handle caching, how we can implement feedback loops, how to monitor the performance or the accuracy of the results. So stay tuned. In the coming videos, we will cover all the topics one by one.